Hello everyone, I'm Jusong from EPFL. In this presentation, I will give you an introduction on OPTIMADE and how AiiDA integrate with OPTIMADE, so the structured data from AiiDA database can be served with OPTIMADE specification. So first of all, OPTIMADE is a combined effort from many people and organization to create a common API for materials database. A lot of big players in materials database have come together to try to describe what structured data is and how we communicate it. Among those are like COD, the Materials Cloud, the Materials Project, Nomad, AFLU, and so on. Some of whom you may know. Different database may implement different API to query the data from their database. Even though the data entities are all just the crystal structure. As example, the AFLU and the COD has different format to query the oxide silicon from the database as shown here. The problems are to query the same thing for different database. Different API requests are using, and which is hard for new users to handle the query syntax. And two, different database use different ways to describe the data and the request. So this may cause that the same query will end up with different results. OPTIMADE is a standard for query structures data from the database. If the database conforms with the OPTIMADE specification, the same request can be used for the same query purpose. The specification then defines a grammar for filtering entities against these attributes, allow the previous oxide silicon filter example to be expressed in a common way. Altogether, the universal OPTIMADE URL, where only the implementation URL changes, only this part needs to be changed. For other database, only base URL changes, not the need to learn a new API syntax to query. So for the previous example, we all use the same query request for different database. And I'd like to highlight and use the last example, our MC3D database held on Materials Cloud, to show how we use AiiDA OPTIMADE to integrate the OPTIMADE and AiiDA database. So the MC3D is a curated set of relaxed three-dimensional crystal structures based on broad safe data from the experimental database, the MPDS, COD, and the ICSD. The relaxation calculations on structures are run by AiiDA, so they actually have an AiiDA database with thousands of raw and relaxed structures and behind. In the Materials Cloud, we use the AiiDA OPTIMADE to serve these structures data in an easy way. Now, the AiiDA already has a REST API where you can inspect all the nodes and calculations and structures. However, the AiiDA OPTIMADE repository provides you another REST API, another way to communicate what is in your database, specifically the structured data nodes compatible with OPTIMADE. It is implemented based on the OPTIMADE Python tool. The query of the structures from AiiDA Postgre database through AiiDA Python API, and now it's supposed to query the structured data and the safe data stored in AiiDA database. And assuming you have already run some AiiDA calculation on crystal structures, then you have some structures data in your AiiDA database. So moreover, it is now already support the AiiDA 2.0, And I will show you how easy it is to have a Optimade compatible structures database served by using the AiiDA Optimade. Assuming you already run some simulation from structures, the structures are already in the database. All you need is first install the AiiDA Optimade, and then initiate the attributes of the structures data in the database by this command, and then run the server by AiiDA Optimade run, and that's done. And you can make the API call by browser, for example, or any other way you can make the request to query for the data. So suppose we already have the AiiDA database. Our profile name is the my structures. I just created and import a lot of structures into this profile, the database. So let's check whether we have any structures inside. We can query the data by using this one. By using this one, we will check that all the structure data we have in the database. We have 1092 structure database, structure data, and also we have some provide some SIF data as example here. SIF. Yeah, we have 528 SIF data in the database. So now we want to serve all these structured data in an optimized way. Let's do it. So first we just need to install the Optimade client. Once we're done, we can use the Optimade this initialize command to initialize the all the data entities, so they have the information of the Optimade that needed by the Optimade. So to initialize it, it will take some time to initialize all the database. As we can see, we need to go through all the 1,620 structures data in our database. Yeah, let's just do it. Okay, so we are done. We have all the documents have been initialized. So now we can start the server and run. Yeah, that's it. As you can see, the server is running, and we can go to this address to query the data. Let's go to the browser, and we can query for. Let's see. The info will show the information of this Optimade server, and it shows that we have these available endpoints. To query structures, we need to use this one, and for the others, you can check the DOS, the redoc, and the links, and the Open API JSON file, the specification. To query the structures, we'll put the filter. We want to our request. Here is an example. We want to query for the elements that has all inside the components. They included the carbon, the oxide, the fluorine. So I also want to include the alumina, so that the results are much less, so we can show all the results. It's not correct. Elements has all. Yeah, I forgot the carbon and the alumina. We have got the results. They are all. Let's check. We have got 2 results, and these are the information of this structure. Finally, I would like to show you the Optimade client which you can find at this URL. It is one of the widely used tools in the Materials Cloud that this tool allows users to query for structures from various database from the Materials Cloud, from the Materials project through this client. This all under the hood is all based on the OPTIMADE. So here I will show you the OPTIMADE client in our Materials Cloud. The OPTIMADE client deployed in the Materials Cloud. So you can find the tool from the Materials Cloud, the work tools, and the OPTIMADE client. So when you open the client, you will see a periodic table and where you can start the search. So first you need to select the database that you want to query for, and we use our database, the Materials Cloud one, which also contains a bunch of sub database. Flagship database is the MC3D and MC2D, the Materials Cloud 3-dimensional crystal database. So let's choose the MC3D one. You have choose the database. You can see the periodic table is lighted, and you can select the elements that include in your compounds. Let me just show you an example of the, let's say, aluminum oxide, and it maybe also included the sodium. Let's see. You can also exclude the elements by just click twice, and it will become the red one. It means that your compound will not include the fluorine. Let's search, see whether we can find anything. Yes, we find 37 structures, and you can check the structures here. And this is the information of structure. You can check another one, and you can download the structures in different formats. And I want to highlight here, you can directly use this one to generate the QE inputs. So you choose the structures, and it will prepare with these protocols. You can quickly generate the quantum espresso inputs with these structures, with all the parameters already been set. You can download all that input file with the presentations we provided. The OPTIMADE client is implemented as Python Jupyter widget, so which means that you can also use it in any of your Jupyter notebook as a structures fetch tool. We use it for our AiiDA Lab Quantum Espresso app, which is a tool to run Quantum Espresso by just open the browser and click the mouse. So this is an example that we just need this couple of codes. We can have OPTIMADE query widget in our application. I'd like to thank that all the people actively contribute to the AiiDA Lab and the OPTIMADE. Thank you for your attention.